Ignition sequence start.
Good morning. Here's a view of the activity inside the International Space Station Flight Control Room at NASA's Johnson Space Center in Houston. Specialists like these men and women are on duty here around the clock to keep tabs on the space station's systems and assist the astronauts and cosmonauts with their daily tasks of science research and station maintenance. And today, Station Commander Sergei Ryzhikov and his crewmates are preparing for another extravehicular activity starting Saturday morning, in which flight engineers Mike Hopkins and Victor Glover will float outside the station for the 6th spacewalk of Expedition 64.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Leah Cheshire. Space station maintenance and upgrades continue with another spacewalk on the schedule. NASA astronauts Victor Glover and Michael Hopkins will float outside the airlock on March 13th for a scheduled 6.5-hour spacewalk. The pair will continue tasks scheduled for previous spacewalks, like the venting of the early ammonia system, installing a stiffener on the Quest airlock's thermal cover, and connecting cables for the new Bartolomeo science platform outside the Columbus module. Live coverage of the spacewalk will begin at 6 a.m. Eastern Time, with the astronauts scheduled to exit the station at 7:30 a.m. You can watch the action unfold on the agency's website at nasa.gov/live. Living in space creates unique challenges that require innovative thinking. When dispensing tape became a problem, students got involved. The high school students united with NASA to create a hardware program, also known as Hunch, design and create products used by NASA. In space, crew members often need to stabilize themselves with one hand while working, making it difficult to perform two-handed tasks, like tearing tape. So Hunch students designed a tape dispenser that's now being used on station.
The key things I like about it is you can basically operate it with one hand, and up here, you oftentimes using your other hand to stabilize yourself. So very easily it goes on the guide rails. You can see it's already locked in place. And slide the roll of tape on, and then you can pull it off, again one-handed, and I've got my very clean-cut piece of tape.
On April 9th, 3 new residents will launch to the International Space Station, one of them being NASA astronaut Mark Vande Hei. Next month, the station crew will grow to 10 people upon arrival of the Soyuz MS-18 spacecraft aboard the International Space Station. Vande Hei will serve as a flight engineer for Expeditions 64 and 65 alongside Roscosmos cosmonauts Oleg Novitsky and Pyotr Dubrov. The station crew will shrink to 7 members again about 1 week later when Kate Rubins, Sergei Ryzhikov, and Sergei Kutsverchkov return to Earth. That'll do it for us this week on Space to Ground. We'll see you next time.
The spacewalk that Hopkins and Glover will do tomorrow will begin in the same way all other International Space Station spacewalks do, with the lengthy process of getting into the spacesuits that support the astronauts as they float in the vacuum of space. Want to see what that looks like? Well, here's an accelerated view of the process in which European Space Agency astronaut Luca Parmitano helped NASA's Drew Morgan and Christina Cook get ready for one of their spacewalks on Expedition 61. Hopkins and Glover arrived at the space station in November on the SpaceX Crew Dragon Resilience with crewmates Shannon Walker and Soichi Noguchi on what is the first operational mission of that commercial vehicle. So what does that mean? And what are these astronauts doing in space? And how long will they be there? I know, a lot of questions. Well, who better than the crew members themselves to answer those questions and more?
I'm Victor Glover, NASA astronaut, Navy commander.
I'm Dr. Shannon Walker, NASA astronaut.
My name is Soichi Noguchi from Japan.
Hi, I'm Colonel Mike Hopkins, United States Air Force and NASA astronaut. I will be the commander on NASA and SpaceX's Crew 1 mission to the International Space Station.
Crew 1 is the designator for the first operational mission of the SpaceX Crew Dragon. So it's a new vehicle.
We are starting the phase where we are flying astronauts. NASA is flying astronauts to the International Space Station on commercial crew vehicles.
We're going to go up and we're going to stay for the full long duration from 6 to 7 months long.
And one thing that's very different about our flight versus Doug and Bob's is we'll have 4 people. How do 4 people live and operate on such a vehicle?
We want to get our Crew Dragon spacecraft to the space station and home safely. Flying the spaceship is one piece. There's also the very important mission of being on the International Space Station.
And of course, once I arrive on the space station, I'll be a board engineer and do lots of science and maintenance and spacewalks, robotics, all kinds of work.
And then at the end of our mission, our stay on ISS, I'll command the vehicle and bring us back home and land, and then at that point, it's all done. Well, actually, it's not all done. Once you get back from the mission, you have a long post-flight period. You know, you go through the day-to-day training, the day-to-day operations to get ready for it.
There's the basic competencies, I guess, flying T-38s, the high-performance jet flying that we do, the NBL training, the diving in the full pressure suit, the space suit, to train for spacewalks, robotics training, and I'm still taking Russian classes.
Science payloads, and also the maintenance tasks, and also some of the assembly tasks remain on the space station.
How to handle emergencies on the space station, to how you fly the Crew Dragon spacecraft.
We've been going out to SpaceX and working with them from a training standpoint as well as from a development and verification and testing standpoint.
Also, in many ways, having trained in spacecraft and for spaceflight all over the world, training is training, and it's all about the same. You start off with theoretical work, and then you move into the practical inside your spacecraft.
You know, it's a great honor, first and foremost, and looking at all their experience, it makes me, one, comfortable that there's so much experience and so many ways that I can learn from them, but at the same time, I want to be ready and able to contribute.
My kids, my wife have said, "You don't go to work anymore, do you?" It's like you go and just play all day, and that's what it feels like when you come here to JSC and you get to train. And it's much more serious than that, right? It has real consequences. But at the same time, you know, I just absolutely love it.
To be able to fly a new spacecraft to our home of almost 2 decades in low Earth orbit is just an amazing accomplishment.
Americans really should be proud of this achievement. But for the rest of the 7.4 billion people, I will open the door for you. This is an international corporation, and all the other people around the world have a chance to ride on this Crew Dragon. So this is a new era.
I think it is just tremendously exciting and fascinating to know that kids are growing up today that have always had people living in space and always had the countries working together for science and engineering objectives.
All for one, Crew 1 for all.
The International Space Station's mission is to encourage commercialization of spaceflight and space research, and to serve as a science laboratory to support future exploration into deep space, and to promote international cooperation. All of those goals come together when the station is used as a launch pad for a series of small satellites known as CubeSats.
Think of the International Space Station, and most likely you imagine an orbiting laboratory where scientists observe how plants, materials, and humans react to microgravity conditions. But during the past decade, the station has also served a very different role, that of being a business incubator. And this is one of its star products, the CubeSat. The CubeSat is one of many types of satellites now found in space. It is one of the smallest. One unit is a compact 10 by 10 by 10 centimeter cube and is commonly referred to as 1U. And it can be deployed for a fraction of what its larger cousins cost. Early small satellites launched from the station were literally thrown into space by Russian cosmonauts. In 2012, crew members began utilizing the airlock in the Japanese Kibo module to deploy up to 6U of CubeSats per airlock cycle. And not long after, the American company NanoRacks built and began operating an even more robust deployer on the station, capable of launching up to 48U per cycle. That changed everything. Mike Reed is the manager of Space Station Business and Economic Development at Johnson Space Center. He notes how one of NanoRacks' first customers, Planet, leveraged the new launch capabilities aboard the space station. Planet wanted to take high-resolution photos of Earth. While you can take pictures from the space station, your coverage is limited by the station's orbit. With multiple CubeSats, however, you can position them to cover almost any point on Earth. In a relatively short time, Planet deployed several generations of CubeSats from the space station, proving the viability of their technology approach and their business model. With these successes, Planet quickly expanded to an operational fleet of over 150 satellites deployed using commercial launch providers. This fleet gives them the ability to image the entire Earth's landmass every day. Planet's imagery is now in high demand by companies and governments who use this big data in the fields of agriculture, forestry and land use, mapping, and disaster response. Within a decade, the company has grown from a true startup to employing nearly 500 people. Multiple companies are now building small launch vehicles specifically to deploy CubeSats and other small satellites into low Earth orbit, for use in a variety of ways for companies as well as students and nonprofit organizations. CubeSats are being used to provide internet services to even the most remote regions of the planet. They're helping build better weather and climate models to improve weather forecasting. They're enabling text messaging for your phone around the globe, even without a cell signal. CubeSats are also leaving the planet. The first and second interplanetary CubeSats accompanied NASA's InSight lander on its recent mission to Mars, relaying data about the spacecraft as it entered the planet's atmosphere. Some CubeSat missions will serve as pathfinders to help map the way for the Artemis missions to the Moon. And 13 CubeSats will launch on the first mission, Artemis 1. Reed concludes with this observation. Today, more and more, a single large and expensive satellite is being replaced by one of the newest members of the satellite portfolio, a flock of small, less expensive, yet very powerful CubeSats. Affordable access to space has broadened the station's capabilities in a way that, frankly, was never envisioned. However, that access has enabled CubeSats to become a sustained commercial success, contributing significantly to the growing space marketplace. For more science and research from the International Space Station, go to www.nasa.gov/ISS-science. To discover more about the space on, around, and beyond our planet, visit science.nasa.gov.
The range of science research being done on the International Space Station today is remarkable, and the station program's Science Office hopes you can help expand it. If you've got a hypothesis that needs testing that requires eliminating gravity as a variable, have we got a research platform for you?
Hi, I'm NASA astronaut Megan MacArthur. Did you know there's a research laboratory in space? It's the International Space Station, and it's a scientific stepping stone that's enabling us to explore farther into space while improving life on Earth. The space station provides a unique environment of microgravity, extreme conditions, and an observation platform that enables researchers from all over the world to test theories and technologies off the Earth in an extreme environment unlike any other. We welcome you to join us on station. You don't have to be a rocket scientist or part of NASA to gain access to this unique laboratory. Don't know much about spaceflight? That's okay. We're here to help people just like you every day. You might be curious about funding, capabilities, access, or maybe you just don't know where to start. Give us a call or email. We'll ask you some basic questions about your objectives, which will help us point you to the right people who could make your experiment or testing your technology possible in space. Visit nasa.gov/station opportunities for more detailed ideas, answers, and contact information, or find us at the Station Research Client Helpline. So welcome to the International Space Station. You'll soon be part of a worldwide group of researchers making discoveries on this amazing orbiting vehicle, all for the benefit of our planet and future exploration beyond.
In addition to being the hands-on laboratory assistants for science research done in space, the International Space Station's crew members use some of their time to share the experience and help students learn about scientific concepts. Astronaut Scott Tingle put together this demonstration video about the importance of nutrition for men and women who are of this planet, if not on it at the moment.
Hello, and welcome to the International Space Station. My name is Scott Tingle. Here on the space station, we live in a microgravity environment, which makes eating here a very unique experience. To stay healthy, we have to maintain a nutritious diet, just like we would back on Earth. Let's go take a look at some of our food and drinks and check out our meal preparation area. During long-duration spaceflight, we have to make sure that we receive enough energy, proteins, and vitamins. Our food lab back on Earth makes sure we get plenty of each as they carefully prepare, test, and package everything. We combine all of this excellent nutrition with exercise to ensure our bodies stay healthy and strong while we're here. We eat 3 square meals a day just like we do on Earth, maybe throw in a snack or two. One of my most favorite foods to eat are natural raisins. Here on Space Station, we have to keep our calories up if we want to get all our work done. And the carbohydrates in these raisins really help. And they're kind of fun to eat, too. And how do we stay hydrated in microgravity? With these special pouches. They're filled with water, and we use a straw that has a one-way valve that prevents water from floating out of the pouch while we're not drinking from it. Here's a liquid drink. This is a tropical punch for today. I love drinking fluids on station. Here on station, we have a pretty cool food preparation area. We have a place to get fresh water for us to drink or to put in our rehydratable foods. And we also have an oven to put food in. We pick out some of our favorite foods, chicken fajita for me. Put it in the oven. Close the door and turn it on. In about 15 minutes, I'm gonna have a warm meal. Thanks for exploring a little nutrition with me. I'm gonna send you back to Earth so you can create your very own astronaut menus. See you again soon.
The work being done on the International Space Station is also supporting NASA's next major effort in human spaceflight. The Artemis program will return astronauts to the moon in a few years using the Orion spacecraft, the Space Launch System rocket, and the ground systems that will make those missions possible. Here's a quick look at the latest milestones achieved as we move closer to the first flights of Orion. International Space Station crew members who spend many months in space, like the Expedition 64 crew members have, get the opportunity to see changes on the Earth below them over time. One of their European Space Agency colleagues, who has a full year in space to his credit, says he has noticed the human influence on the planet we all call home.
Okay, 3, 2, 1. Well, I've been lucky enough to spend exactly one leap year on the space station, 366 days. So you can imagine that in 366 days, you get to see the Earth quite a bit. Even though we are so busy on the space station, we do try to look outside and glimpse what's flying below us any chance we get. Was a part of me, the dreamer, the little kid that started dreaming about this whole experience now basically 40 years ago. That part of me was still there, unchanged for 30 or 40 years, and just marveling incredulously at the beauty of it all. And I would see clouds and green and rivers, and it would just completely fill my eyes. The difference in observing the world or the universe from inside the space station, looking through the windows, or being outside is what I describe as the same level of interaction that you can have looking at a beautiful aquarium from the safety of a room. When you're outside and all you have is a helmet and maybe 1.5 inch of plexiglass in front of your eyes, you can see details and colors and shades, the level of detail that you can capture and the way you experience that universe is going to be very, very different. You want and you feel that you have become part of it, and you can develop that sense of belonging. I think that the first impact of the first flight was that I did see and I did sense how fragile, how small the Earth is. We are used to think of the Earth as something so vast and big, and we don't think that what we do, our daily life, can affect such a vast system. But from space, you get a sense that every individual, every living organism is somehow connected. Seeing the city lights at night, where a place like Europe or the United States or Asia, densely populated, everything is so interconnected, and all those lights and all those lives are apparent. They are right in front of you all together, and you think that all we are doing somehow as an effect on everybody else. You come back from an experience like that thinking that that's what's happening, and then you can see the effects, both the positive ones but mostly the negative ones, in a second flight. And I think you have to acknowledge and grow an awareness, and with that awareness comes the desire to share the experience and share that awareness. It's understanding that the science that's telling us how we are changing and influencing the world has solid mathematical and solid mathematical base. And then you see the effects of it and you just interiorize it, you make it your own experience. And I think that that's what happened. That's why astronauts develop that awareness of and the desire to help the environment somehow, in any way they can.
If you want another look at any of the stories we featured today, you can always find them on YouTube and Facebook, where you'll also find lots of other great features on a wide variety of NASA topics, so be sure to look around. If you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast, our weekly show talking to folks involved in all areas of space exploration. Today, Gary Jordan learns a brand new acronym while getting the story on NASA's next effort to send humans into space for year-long missions on the International Space Station to get us better ready for the longer missions coming up out into the solar system. Go to nasa.gov/podcasts for this week's episode and all our previous episodes, and the full library of all NASA podcasts, which are all also available on Apple Podcasts, Google Podcasts, and SoundCloud.